Okay, so welcome back to this next video in which we are discussing tertiary lymphoid organogenesis in chronic inflammation. Okay, so we're currently looking at the pathways by which you induce this change in the endothelial cell that is the thing which causes the tertiary lymphoid organogenesis to begin, because these altered endothelial cells, which are going to become high endothelial cells, they are going to start recruiting naive T cells and naive B cells from the blood and taking them into the interstitial fluid of the inflamed area. Okay, so we've discussed that this change is going to be produced by T lymphocytes which are in the inflamed areas, which are not naive T lymphocytes. These are fully differentiated T helper 2 cells, T helper 1 cells, cytotoxic T cells. They have lymphotoxin beta on their surface. This will bind to the lymphotoxin beta receptor, which will then lead to the activation of the MAP kinase ERK kinase 3, and also the TGF beta activated kinase 1, TAC1. And these two enzymes will phosphorylate the IKK beta, standing for the IK beta inhibitor of NF-kappa B kinase beta. And that will activate this enzyme, which consists of the inhibitor of NF-kappa B kinase beta, the inhibitor of NF-kappa B kinase gamma, the inhibitor of NF-kappa B kinase alpha, all of those together. And when you phosphorylate specifically the inhibitor of NF-kappa B kinase beta within this complex, what will happen is this complex will now phosphorylate inhibitor of NF-kappa B proteins, which are sequestering and inactivating our NF-kappa B transcription factor here. Okay, so the sort of prototypical inhibitor of kappa B protein to have here is the inhibitor of kappa B alpha. Okay, so this is the main inhibitor of NF-kappa B protein. However, there are others, and some that are going to be phosphorylated by this complex also include the inhibitor of NF-kappa B beta, and also the inhibitor of NF-kappa B epsilon. Okay, so these are 3 examples of inhibitors of NF-kappa B proteins, but the main one, as I say, is this alpha one. And what's going to happen is this enzyme complex is going to phosphorylate the inhibitor of NF-kappa B protein. However, this does not cause the dissociation of the inhibitor of NF-kappa B from the NF-kappa B complex. Okay? Instead, what has to happen is you have to firstly ubiquitinate this inhibitor of NF-kappa B protein. Okay? So phosphorylation happens first, and then ubiquitination is going to follow that phosphorylation. So the phosphorylation is going to trigger ubiquitination, and when you get the inhibitor of NF-kappa B ubiquitinated, then what will happen is that will be targeted for proteasomal destruction, and that's what triggers the dissociation of the inhibitor of NF-kappa B from this NF-kappa B dimer here. Okay, so you will phosphorylate the inhibitor of NF-kappa B protein, and this will result in the inhibitor of NF-kappa B being ubiquitinated. So we'll add on another group here, which is ubiquitin. Okay, and now what will happen is the inhibitor of NF-kappa B will be sent for proteasomal destruction, and somewhere in that process, what happens? Okay, so if we can imagine it now going to the proteasome, what happens is the inhibitor of NF-kappa B is going to go through the proteasome and it's going to be destroyed. However, the NF-kappa B that it's bound to is not going to be destroyed. Instead, it's going to be freed from the inhibitor of NF-kappa B when the NF-kappa B goes through the proteasome. Okay, so the proteasome is a quite terrifying thing in the world of molecular biology. Proteins go in one end, and fragments of proteins come out the other end. Okay, so what will happen is this ubiquitin group that we have now added on to the inhibitor of NF-kappa B is going to mean that it will be targeted for proteasomal destruction. So it's going to go into this proteasome, it will be chopped up, and when it's sort of being fed through this proteasome, you can imagine that the NF-kappa B will go free. So here's this NF-kappa B. So it doesn't get destroyed by the proteasome. It's not as though it's dragged through too. So the purpose of this discussion is to highlight that it is not the phosphorylation of the inhibitor of NF-kappa B which causes it to dissociate from the NF-kappa B. Instead, it is that the inhibitor of NF-kappa B will be phosphorylated, and this will lead to its ubiquitination, and then when it's being destroyed by the proteasome, the NF-kappa B will then be free in the cytoplasm of the cell. Okay, and it will then be able to go on and activate transcription of certain genes.